look at that video. Okay, this will show you the functioning of the electroscope, how it basically works. Meanwhile, where are others? Only you guys have joined now. Anyways, so have a look at this video.
Gold leaf electroscope. Gold leaf electroscope is an instrument that is used for detecting the presence of electric charge and its polarity. The instrument is also used for measuring the potential difference. The important part of the gold leaf electroscope are shown in the picture. The two extremely thin gold leaves are attached to the lower end of the brass rod fitted in a glass jar through an insulating cork of rubber. A circular metal disc is fixed to the upper end of the brass rod. The gold leaves are extremely thin conducting foils that have low mass per unit area and are flexible, so they respond very quickly to small electrostatic forces. Charging an electroscope by conduction. Let us see how an electroscope is charged by conduction. Charging by conduction involves the contact of a charged object to a neutral object. Here we can see a glass rod and a silk cloth. Now, when a glass rod is rubbed with a silk cloth, then the glass rod becomes positively charged. Touch the positively charged glass rod with the metallic disc. What do you observe? We observe that as soon as the positively charged glass rod is brought in contact with the neutral metal disc, the gold leaves diverge due to the presence of similar positive charges on them. Now, remove the glass rod. We notice that the leaves still remain diverged. This shows.
No, okay. Here the leaves are still separate from each other. They are still diverged. So what should I do so that the leaves closes? They return to their normal position. What should I do? Yes. If you guys can recall.
So we can bring a negative charge object close to the rod.
Okay, we can do that, or we can basically, yes, Chakrika?
Nothing, sir. Go on.
Okay, we can basically touch the metal disc. Okay, now let's see further what happens here.
That electroscope is charged by conduction. Now, touch the electroscope with your hand. What do you notice? We find that the gold leaves collapse. This indicates that
So what does this shows? This shows that our body is a conductor, right? So those charges are conducted into our body, and via our body, the charges will go to the earth. Getting it now? So thereby, this electroscope is now devoid of charges. Now devoid of charges. There is no more charge here, so it folds. Okay, now it's no longer diverged.
Sir, I have a doubt.
What?
Is it because it is balanced after we touch the metal disc?
How we can see that, like the charges are taken away from it, so we can see the object is now neutral. Okay, now the object is not having any positive or negative charge on it right now. So as soon as we touched it, so thereby all the charges went to our body, and from our body it went to the earth. So we can see the charges kind of got balanced. We can say that. Getting
Yes,
it now?
Yes, sir.
What happens to the charges? As you touch the metal disc, the electrons from the earth travels through the body and pass from the hand to the metal disc and neutralize the positive charges. We can also say that earthing takes place as we touch the electroscope. An electroscope can be negatively charged.
So an important concept here is like when we touched it. So thereby our body being a conductor, so some charges like the electrons from the earth goes into this electroscope as well. So in that manner, the number of charges are getting balanced here. Right now, That's why it folds away. It folds like they are no longer separated from each other.
A negatively charged ebonite rod
Now,
is brought
previously
in
we
contact.
did took the glass rod, we rubbed it with a silk cloth. The glass rod was positively charged. We can charge it. We can charge it negative also. So we have taken an ebonite rod here.
With the metal disc. When it touches the metal disc, the gold leaves diverge due to the presence of similar charges on them. As soon as we touch the metal disc, the negative charges flow to the ground, thus discharging the electroscope.
So that is the thing. Like what is happening here? This, let me take this image here. So like as we brought a positive charge in contact with this metal disc, as we brought a positively charged glass rod in contact with this now, so thereby what is happening, the positive charge flew in this, right? So the gold leaves are diverged from each other, right? Now gold leaves gets separated from each other. So at that time when you will be touching this metal plate, when you touch this metal plate, so what happens, the electrons from your body flows into this. The electrons from the earth flows into our body, and via the body the electron goes into this. So thereby this electroscope at that time now acquires the negative charge also. So the negative and positive charges are balanced, so thereby the body becomes neutral and the leaves will fold away. The leaves will be closed like this. Getting it, you guys? Yes, Khadija, how are you?
Good, sir. How are you?
Yes, I'm also good. Khadija, where have you been? Like you have been you have joined class after a time, after a long time.
Sir, actually, it was an issue with my laptop. It wouldn't let me join the classes.
Oh, okay. That was the problem. Okay, okay. Anyways, let's continue from here. Like right now, the chapter some natural phenomena is going on. Okay, that chapter is right now going on. So, in the video, what you guys saw in that video, like in this electroscope, when I brought a positively charged rod in contact, so thereby the gold leaves became positively charged. So they will be remaining separated from each other. But when I place my hand on the top of metal plate, so thereby electrons travel from the earth. Electrons travels from the earth and from my via my body it goes into this, and then the number of charges becomes equal. Positive and negative charges becomes equal, so the body becomes neutral. Now the gold leaves will no longer remain diverge from each other. They will close itself like this. Got this now? This was in the case of the when you are bringing a positively charged rod. But if you were to bring a negatively charged rod, then what happens? If you were to bring a negatively charged rod, in that case, what is happening? Like let's say that you are bringing a negatively charged rod in contact with this. So thereby, this will be acquiring negative charge, right, Chakrika? It sorry,
Yes, sir.
negative. So it acquires negative charge here. In that case, also the leaves will be diverging from each other, right now. In that case, also leaves are diverge from each other, and we had brought the ebonite rod. Ebonite rod. So when ebonite rod is rubbed with a wool or a silk cloth, it acquires a negative charge, while the glass rod acquires positive charge. So when you bring a negatively charged ebonite rod in contact with the metal plate, so this rod and the gold leaves acquire negative charge, so they get they are diverged from each other. But at that time, when you will be touching it with your hand, let's say you are touching it with your hand. So in that situation, what is going to happen? That the electrons will travel from this electroscope. The electrons are going to travel from the gold leaf and from the rod into your hand, and from your hand it will go into the earth. So here earthing takes place. Earthing has taken place here. Then what will happen? Now this will become neutral since it loses the negative charge, it loses the extra charge on it. Now the leaves will fold away. The leaves will now remain in its original position. Got this, all of you?
Yes, sir.
That is the thing here. Okay, now, Khadija, you can revise this from the recording about this electroscope. Today we are going to continue with the next topic. Okay, now. Also have a look at this, like earthing. It's basically the process of transferring charges from a charged body to the earth. And why it is done, like here you can see like earthing has been done. This is the earth wire. It is connected to the different appliances in our house to prevent us from electrical shocks. So this earthing, it is provided in the building to protect us from electrical shocks due to any leakage of electrical current. Like in some electrical appliance, if there is a leakage of electric current, so we might get electrocuted, we might get electrical shocks. So that is why it is done. So we have taken a metal rod, preferably we use iron rod. Okay, and we'll be basically hammering it into the ground, and the wire is connected here. Make sure that it is rust free, it is not rusted. Okay, now we should make sure that it is properly connected, otherwise the earthing will be loose. Okay, answer the first question, which is not a natural phenomenon out of these. In the first question,
So earthing.
it's not a natural phenomenon, it's done by we humans. How many types of charges are gained by rubbing objects?
So two.
Two. Yes, Khadija, two charges now, positive and negative respectively. Okay. Okay, where is the lightning rod attached to protect the building from the lightning? Like we are going
On the
to
top,
on the top. Exactly. Okay, no. Now what is amber?
Resin.
It's a resin. And what is resin? It's a waste product secreted from the
Just bark of the tree.
bark of the tree, right now. So like Greeks were aware of this, like when this amber, when it was rubbed with silk cloth, it started to attract tiny feathers or tiny objects. Okay, now also so many fossils can be found in amber. Like here you can see a fossil of a mosquito. Okay, now that is in this amber. Getting it? All right. We did learn about lightning in the previous classes. Okay, so in this we learned about how basically lightning happens. We know that when there's a storm, for example, so when the hot air will be rising up and the raindrops are falling down, so this leads to separation of charges in the cloud, meaning that the warm hot air is rising up while the raindrops are falling down. So due to this opposite movement of the air and the water, it leads to separation of charge in the atmosphere. Okay, as a result of this, what happens, the negative charge gets accumulated in the lower edges of the cloud. As you can see here, this is the negative charge in the lower part of the cloud, and the positive charge gets accumulated on the top part of the cloud. Getting it now? And ground is accumulated with a positive charge all over here, right? And there comes a time like also simultaneously, if the speed of the wind increases, so this charge will also start to multiply further. Getting it now? That's why or usually lightning is more common when there's a storm. Getting it now? When it's a calm weather, when the weather is very calm, so lightning is not very common. But if it's a stormy weather, so lightning will be very common. It is obvious that there will be so much of lightning. Getting it, guys? And lightning can be very deadly. Like in USA, like there are about 25 million or 25 lakh cases of lightning every year. 25 lakh lightning is observed every year in United States of America, and it can be very deadly and can be very fatal. So if increase in the there's an increase in the wind speed, the charge will multiply further. Getting it now? Okay. Further here, you guys can see that there is discharge of huge amount of current from the cloud into the earth. What we know about discharge, when a body loses, like whenever there will be a huge amount of loss of current between two objects, so there will be discharge of current here. Like now, like generally talking about discharging, what we have learned, like when a charged object loses its charge, it is said to be discharged. So here the charge object is this cloud. So this cloud is losing its charge into the ground. So there's a huge amount of electric discharge in this case. Also, As we know that air is usually a poor conductor of electricity, but due to heavy amount of charges that develops here now, it is unable to restrict the flow of charge here. It is unable to restrict the flow of electric current after some time, right? So here what is happening, this negative charge, like this negative charge, okay, and this positive charge on the ground, they meet, and they are meeting, and because of that you see this flash in the sky. So the negative charges and positive charges meets, which result in the production of electrical sparks in the form of a streak of light, and there's sound also. Okay, so this streak is called lightning, and the whole phenomena is called as electric discharge. Also, this can occur between two clouds or within a cloud also. This electrical discharge, it can occur within two clouds also, within the same cloud also. Like here you can see, notice over here. Notice at this place. Over here, we are going to see that there will be intra-cloud flashes also. Like you guys might have noticed it here, right? So they can be discharge within the cloud also, or between two clouds also. They can be discharge of electric charges. Is that clear? In fact, we
No,
did
sir.
also learned about why lightning strikes tall buildings easily. Because tall buildings, or say for example tall trees, they provide the shortest pathway for electric charges to be conducted into the ground. So thereby, in order to protect them, we have to install a lightning rod. We have to install a lightning rod in the buildings in order to protect them. Getting it now? That is the thing here. Then we did learn about what are the safety measures one has to take care of whenever there's a lightning or thunderstorm. So whenever we hear about any alert, so we should run to a safe place like a house or a building. If there is someone in a car, or if there's someone in a car or in a bus, they should remain inside the car or in a bus. If they are outdoors, I'm talking about the outdoors, okay, and not inside the house. If the person is inside the house, what are the precautions they should take care of, and if they are outdoors, what are the things they should do? Okay, like talking about the outdoor safety, so one should find a safe spot. Okay, now one should not stay in open place like in an open vehicle like a motorbike, a tractor, or open fields. Getting it? Also, one should not carry an umbrella during the storm, or if a person is in a forest, he should hide under the short trees. One should also not stand near to any electrical cables, any poles, or any other metallic objects. Okay, now one should squat low on the ground instead of laying down. Like in this position, one should lie down. I guess I had that image. By squat down, I mean to say this, like the person should be sitting down in this position like this. Getting it? What I'm trying to say? Okay. In this position, the person should sit. Basically, the person should know, like I would say that they should, instead of lying down, they should squat low in this manner. Okay. Like crouch with your head in between your hands. Crouch your head between your hands like this. Getting it? Then what are the indoor safety? So one should not use wired telephones, right? And usually they are no longer in use. So one should not be using the telephone. One should stay away from the windows and the doors. One should not be taking a bath. Unplug all the electrical appliances. Do not wash the dishes because the tap water, let's say if the water tank is also situated on the top of the building, so if somehow that is also struck with lightning, so all the water in the pipes would be containing lots of charge. The person might get electrocuted. So these are the some common things one should take care of. Okay. Also, while we were looking at this lightning conductor, important thing to be noted down here is that this lightning conductor has to be a conductor, obviously, has to be a metallic object. So what it does now, it allows the flow of electric charge to the ground, right? Here you can see in the ground rod, like there could be a ground rod like this, and it could be connected to a huge piece of copper plate. Okay, it could be connected to a big piece of copper plate for better conduction of charges into the earth. So one end of the rod is open in the air, other one is buried inside the earth. Getting it? So this consists of pointed ends, which are made out of copper wires. Like it's pointed, will be made out of copper wire. This one is made out of copper wire. Another one is also connected to a copper plate here, right? So these are brought down along the buildings. This is brought down along the building and they are attached to a metallic plate in the ground. So here preferably we use a copper plate. Okay. So if lightning hits the building, the copper wire would be carrying the charges quickly to the ground. In this manner, the building will be saved from destruction. That is the thing. So just now we have seen this thing, right? Now we are going to talk about the earthquakes. Okay, now like what earthquakes are. Okay. From lightning, if you guys have any questions, please let me know. From the topic lightning, if there's any question left, from electroscope, please let me know. Otherwise, we're going to move to the next topic. Okay. Talking about earthquake. So earthquake is a sudden shaking or trembling of the earth, which will last for a short duration of time, which will last for a very short period of time. Also, an earthquake, it is caused by the violent movement of rocks deep inside the earth's crust. It is caused due to movement of huge pieces of rocks that are deep inside the crust of the earth. Also, earthquakes occurs every time all over the earth. It occurs all the time. Even right now, like we are having this class, at this time also somewhere there would be an earthquake. Although the magnitude of earthquake will not be that much, might not be that much, so that's why it is not felt. But earthquakes are happening all the time. Getting it? Like on an average, there are about 200 earthquakes. Okay, no? On an average, there are about 200 earthquakes occurring daily. Getting it? What I'm saying? Okay, now that is the thing. Did I say 200? Like no, it's not 200. Like somewhere around 20,000, I would say 20,000 earthquakes. Getting it, guys? So just imagine how many earthquakes are happening daily. But the thing is that the magnitude is not that much. Okay, no? Magnitude is not that much. That's why we don't get to feel it. Okay. So earthquake will also, like we see that it causes immense damage to the house, to life, to different properties, to the buildings like bridges and dams, etc. Lots of people get killed when they get buried under the debris, under the rubbles of collapsed houses and buildings during an earthquake. Furthermore, earthquake can trigger flood also. It can cause flood. It can lead to tsunami also, and even it can lead to landslides also. Right? There was a very there was an earthquake in India by the name of Bhuj earthquake. It was There was an earthquake in India in the year 2001. There was an earthquake in India by the name of Bhuj earthquake. It happened in the district of Gujarat. Okay, so it led to loss of so much of property. Right, and it was one of the major earthquake in the history of India. There have been earthquakes in the northern part of Kashmir also. Okay, in the year 2005. Getting it? There has been earthquakes. Like earthquake not only occurs on land, earthquake occurs in the oceans also. Like in the year 2004 also, in the year 2004 there was a huge earthquake in the Indian Ocean. Getting it? So earthquakes can occur anywhere in the world, but it is most common in the coastal areas where the land meets the ocean or the sea. There earthquakes are more common, more likely to occur. Got the point what I'm trying to say? So all we will see that there will be the coastal areas are also prone to earthquake. Getting it? So as you guys can see in this animation here, two giant pieces of rock are colliding basically here. And as a result of that, huge amount of energy is released, and as a result of that huge amount of energy, we feel tremors on the surface of the earth. So far I suppose you guys have got the basic idea of earthquake. Also, you guys know, like some of the natural phenomena like thunderstorms or like cyclones, they can be predicted by the meteorologist. Meteorologists are the person who predict the weathers, who predict the natural disasters and the weathers. Getting it, guys? But there are some natural phenomena that are uncertain and cannot be predicted very much accurately, and earthquake is one of them. How many earthquake predictions have came to be true? Only some of them. Only some fraction of that. Yes, Chakrika, Gauri, and Khadija. But you would have heard of alerts of tsunami, huh? Like almost a week or 2 week ago, or even a month ago, warnings or and alerts of tsunami or cyclone are released. Hmm? Getting it, guys? But earthquake, it's hard to predict. It's unpredictable. We can't predict it accurately. So it is a natural phenomenon that occurs as shaking or trembling of the Earth's surface, and it occurs or lasts for a very short span of time. Okay, and the main cause of earthquake is disturbances that occurs inside the crust of the Earth, which we are going to study in detail. Also, deep inside the Earth, earthquake would be occurring all the time, but they are not noticeable on the surface of the Earth because sometimes major earthquakes occur on the Earth's surface, which can be destructive. So they are um, we study about them. We can feel that, but most of the earthquakes, their magnitude is very weak. That's why they are not detectable. Okay. Furthermore, earthquakes can lead to loss of life, loss of property, such as buildings, dams, bridges. It can trigger floods, cause tsunami, and landslides as well. Here you can see the before and after images of an earthquake, what an earthquake can do. Now we're going to learn about the cause of the earthquake. So in that, we are first of all going to learn about the structure of the earth. But before that, we know that our earth crust, the crust of the earth that we see, the upper surface of the earth on which we are living, it is not one single piece of rock. It's a giant piece of rock, we can say, and we can say that it is fragmented. It is divided into different segments, and each fragment is known as a plate. Have a look at this image here. These are some of the plates on of the earth. Like you have the Eurasian plate, African plate, Indian plate, Arabian plate, Australian plate, Antarctic plate, South American plate, Pacific plate, North American plate, and some micro plates are also there. The smaller plates are also there, like you can see here. Like this Caribbean plate is there, Cocoa plate is there, Philippine plates, etc. So what we get to see that the Earth's crust is fragmented into different pieces. It is divided into different pieces here. Getting it now? Now, as these plates should be moving past each other, or like when they will be colliding, whenever there will be collision between these two plates, like for example, when this plate and these plates, when they will collide into each other, so this will lead to earthquake. This will cause earthquake. Getting it, guys? But why do they move? It is important to understand why do they move. What is inside the earth that makes them move? So for that purpose, we need to understand the structure of the earth. Okay, so Dija, read this paragraph.
Earth's crust is fragmented, and each such fragment is known as a plate. These plates are constantly in motion and sometimes can collapse under one another, causing an earthquake on the surface.
Okay, let's understand the structure of the earth now. The structure of the earth is divided into different zones, different components, we can say. Okay, now, so they are mainly, the first one is core. Core is further divided into inner and outer core, but just know it as core. Core, then you have mantle, and then crust. So the earth has been divided into three different layers, and each different layer has unique composition. Their physical state is different, their composition is different, they are made out of different chemicals, and their state also varies. Like some of them is solid, some of it is a semi-liquid, some of them is semi-liquid. Getting it? So let us understand about it one by one. Okay. So talking about, first of all, the inner core of the earth. Core of the earth is divided into two parts, as you can see here. Like you have the inner core and you have the outer core. Okay. Now the outer core, it's liquid, while the inner core, it's solid. It's a solid mass, while the outer core is, it's, we can say, semi-liquid. When you look at the mantle is also semi-solid. It's not completely solid, neither completely liquid. So it is semi-solid, while the crust is the solid layer of the earth. Crust is the solid layer of the earth, while inner core, that is also solid. Now, if you were to look at the thickness of the crust, it's about only 8 to 40 kilometers deep. Getting it? Somewhere it can be 12 kilometer deep, somewhere it can be 30, somewhere it can be 40 kilometer deep. What I'm trying to say. But when you look at the mantle, it's about 2900 kilometer thick. Okay. Also, like, there have been various attempts by the humans to dig deep into the surface of the earth, and we have only managed to dig few kilometers into the crust. We haven't even reached the mantle. Getting it? Anyways, talking about the first layer of the earth's surface, that is crust. The crust is made out of mainly two minerals, that is silicon and aluminum. The majority element found in the crust of the earth is silicon and aluminum. So in short, it is called as Sial. What do we call this as? Sial. Getting it, Chakrika, Gauri, and Khadija?
Yes, sir.
When we look at the mantle, what I said about mantle, mantle is semi-solid. Crust, mantle, core. About crust, we learned that it is made out of silicon and aluminum. While talking about the mantle, it is made out of silicon and magnesium. So in short, it is also called as SEMA. Okay, now Si is the short form for silicon, Ma is the short form for uh, manganese, I mean to say. Ma is for manganese. Okay. Getting it, guys? So thereby mantle is in short called as SEMA. Getting it? Then you have the crust, that is knife. So the crust, it is made out of nickel, and Fe here stands for iron. So this is about the composition. This is about the composition of the different layers of the earth. But the important thing here to understand is that mantle is semi-liquid. It's not a completely solid object. So if a solid object, let us say that if a solid object is over, let us say you have a solid object, a semi-solid object here. This is a semi-solid object. So above this, if there's a solid object, so will it rest in a stable state or will it float above it? You guys tell me.
So can you repeat?
My question is that, see, this is mantle. Mantle is semi-solid. It's not completely solid. It can move from one place to another. And above the mantle, you have crust. So will crust also not float above the mantle? Since this is not a solid object, it can move from one place to another. So whatever will be above it, that will also move. Got the point what I'm trying to say?
Yes, sir.
Everyone got it now? Chakrika, you getting it? Khadija, you getting it?
Yes.
No, sir. Can you explain it again?
Okay, sure. See, basically, you can understand it in this manner. Like, say there's something that is a liquid. Let us say something that is liquid in nature. Or just take the example of oceans. So water, like the ships will be floating on the water, right? It will not rest at one place. Even if the engines are not working, it is going to move from one place to another, right? It will not be in a state of rest. That is for sure. So mantle here, that is also not a completely solid object, neither a completely liquid thing, but it's semi-solid. Okay, now between solid and liquid. Getting at what I'm trying to say? Just like
Yes, sir.
jelly, just like a jelly is. Jelly is neither completely solid, not completely liquid. So it is in a state between the liquid and the solid. So if something is above the mantle, so that will also float above it. No? It will be floating above it. It will not rest, but float above
Yes,
it.
sir.
So that is the thing. So the crust that we see, the crust is divided into different fragments. As you guys can see here, it is divided into different fragments here, right? And all these fragments will be colliding onto each other. So wherever they will be colliding, at those places, huge amount of energy will be released, like at this place. For example, at the margins of these plates, at the margins of these plates, earthquakes will be more common. Wherever these plates will be colliding with each other, there earthquakes will be more common. Got this now? That's why you guys will see that earthquakes are more common in this part of India, like in the north part of India and in the northeast part of India. Earthquakes are more common. Getting it now? And in the parts of like in the this part, like in Pakistan, in Afghanistan, and in this part of the world also. Here you can as can see like in parts of Turkey also. There in these parts earthquakes are more common. In fact, in countries like Japan, it is more common. So the countries that are situated along the borders of the tectonic plates, so their earthquakes are more likely to occur. Is that clear so far?
Yes, sir.
Okay, now. So that is the thing. Hope you guys have understood this. Okay. So talking about the core, what we learned, that core is the innermost layer of the. Talking about the crust first of all, it's the outermost layer of the Earth, and the crust of Earth is made out of comparatively lighter rocks than that of mantle. If we were to learn about one more thing, the core crust, first thing we learned that it is the outermost layer of the Earth's surface. Next thing is that the rocks of the crust are less denser as compared to rocks of the mantle. Getting it? That is just one fact. I'm telling you that the rocks present in the crust are lighter as compared to that of mantle. Okay, now. Also, the crust of the Earth is thicker where the land or continents are, meaning that the upper part of the crust, the crust is divided into two parts. Like this is the continental crust, that is basically land. Okay, but the crust does not ends in the ocean now. It will be present under the ocean also. Getting it, guys? Yes, Gauri, Chukrika, and Khadija. Crust will be
Yes, sir.
present under the oceans also. So there it will be called as oceanic crust. Oceanic crust. And which one of them is thicker here? Is the continental crust thicker or the oceanic crust?
The oceanic crust,
No,
the
no.
continental.
Continental crust are thicker. Okay, now. So furthermore, we can say that it is divided into continental crust and then oceanic crust. Okay. Also, keep this thing in mind that like as you guys can see in this diagram, plate margins are here also. These are also the boundaries, like this African plate or this Antarctic plate, right? Here is there any continental plate? There is oceanic crust here now. There is oceanic crust here. So here also under the oceans also earthquakes will take place. And as a result of that, it will cause tsunami. Getting it now? Later on, we'll be learning about that in detail. Okay, how earthquakes under the oceans will cause tsunami. That is the thing. And which one is thicker here? Continental crust is thicker, as we have learned. Okay. Furthermore, we learned that the crust of Earth under is like we have learned, it is thinner here. Also, crust of Earth is made of many huge pieces of flat rocks. Like we can think of it is like tiles on a bathroom floor. Getting it? Like how the tiles on a bathroom floor, there are different fragments of tiles in a bathroom floor. So we can think of the crust of the Earth in that manner. Each piece of the Earth's crust, that is called as plate. You can think of it in similar terms to that of the uh, tiles in a bathroom floor. So there are different fragments of tiles in a bathroom floor. So each part of the crust of the Earth is called as plate. And the plates of Earth on which continents exist, they are called as continental plates. And whereas those plates of the Earth on which oceans exist, they are called as oceanic plate, as we have learned this. Okay. Also, like these plates of crust now are in fact very, very huge. They are very large fragments of Earth's crust. Getting it now? That is the thing. Also, these solid plates which makes up the Earth's crust are floating on the mantle. Are floating on the mantle. Getting it now? So, what exactly is mantle? Inside the mantle? So, talking about the mantle now, like in the mantle will be containing magma. Molten magma will be present in the molten magma is present in the mantle. And since molten magma is very hot, so it will be moving inside the mantle. And due to the movement of the hot molten magma inside the mantle, it produces convection current. It produces convection current. So let me just tell you what basically happens inside the mantle. So say that this is the crust of the Earth. Right beneath the crust, we have mantle. Let us say that this there is that of mantle. And mantle, as we know about mantle, that mantle is semi-solid. It is semi-solid and it contains hot molten magma. It contains hot molten magma. You guys would have learned about convection current in the chapter heat in your 7th standard, where you would have learned that heat is carried from one portion of a given substance to another via the movement of the particles. Like how water boils due to the movement of water molecules from bottom to the top. And again, when it cools down, it goes back to the bottom. Getting it now? Khadija, Gauri, and Chakrika.
Yes, sir.
So something similar will be happening here in the case of mantle also. So what basically happens, as we know that the central region of the Earth, that is mantle, this is the middle layer of the Earth. It is mostly made out of dense solid rocks, while some of the mantle is mixture of solid and hot molten rocks also. Some of them is a mixture of solid plus hot molten magma. Okay. Just like you can think of it in the similar manner, just like lava comes out from the volcano now, in that manner. Also, the question is that why this is so hot? It is hot because of the heat coming from the core of the Earth. The heat is actually coming from the core of the Earth, which heats up the mantle and makes it warm. And this heating sets up huge convection current in the mantle. Because of the heat coming from the core of the Earth, it sets up convection current. So in convection current, basically what will be happening, there you will get to see that like the molten magma will be moving in this manner. It will be moving in this manner. These are the molten magma that is rising up. Once it goes higher up, it cools down and again goes down like this. So hope you guys can understand this, what I'm trying to say. These are the molten magma that is rising up. As it rises up, it cools down and again falls down and again heats up. So a cycle is occurring here, and that is making up a convection current. So convection current takes place inside the Earth's mantle, and due to which what will happen, the plates above it, that is the crust, it will move. It will be moving. Okay, now. So that is the whole thing. Hope you guys are getting it. If there's confusion in this thing, please let me know. Yes?
No,
Okay.
No, sir.
Also, talking about like where the earthquakes should be occurring. So earthquakes can occur, it will occur when the moving plates of the earth's crust would be sliding past each other like this, when they will be sliding past one another like this, getting it? Or when they will be colliding into each other, or when they'll be sliding past like this. We'll be learning about that. But first of all, look at these are the some of the these are the seismic zones, or also called as fault zones. So they are basically the boundaries of the plates on the Earth's crust, and they are weak zones where earthquakes are most likely to occur. So wherever these plates will be colliding or will be sliding past one another like this, those regions will be called as seismic zones. Getting it now? Like I can highlight this like this. These are the seismic zones. Getting it, all of you? These are the seismic zones where earthquakes are more likely to occur. These are the seismic zones where earthquakes are more likely to occur. And all these are called as seismic plates. All these are called as seismic plates, like you have Eurasian plate, Pacific plate, Australian plate, North American plate, etc. These are the different seismic plates, and these are the seismic zones where those plates will be colliding into each other or will be sliding past one another. Now, apart from that, there are some other causes of earthquake also. We are going to go to that, but before that, we are going to learn about some important terminologies related to earthquake. So you guys have a look at this image here. The first important thing is focus. So it's the place inside the Earth's crust where an earthquake will be originating. Where an earthquake will be originating. For example, it could be here, from where the earthquake will be originating, where these two plates are meeting. So that will be called as focus. Focus is nothing but the origin point of the earthquake, from where earthquake occurs. Getting it? Now, if you were to look at a vertical point right above this focus, that will be called as epicenter. So it's the point on the Earth's surface that is vertically above the focus. That is vertically above this focus, that is being called as epicenter. Got this, all of you? Also, the damage will be maximum here. Damage will be maximum in this zone. Wherever the epicenter will be, that zone would have experienced maximum damage due to earthquakes. And these are the seismic waves in which earthquake travels. So earthquake travels in the form of waves. Getting it, guys, what I'm trying to say? Earthquake travels in the form of waves. Okay. Also, these waves can travel in the land and they can travel in the water body also. Keep that in mind. It can travel in the land or it can travel in the water body as well. Now, one more term is fault. So fault is a fracture or zone of fracture between two blocks of rocks. So like we're here, these are two giant pieces of plates, like this one and this one, let's say these are plates. And these plates have moved past one another like this. They have moved past one another in this manner. So thereby a fault is created here. Basically, a zone of fracture has been created here. That is being called as fault, where two giant pieces of blocks of rocks appears to have moved from one another. So those are the terminologies related to earthquake. I hope it should be clear. If there's confusion in it, please let me know. Yes?
sir, can you explain seismic waves again?
Seismic waves.
Yes, sir.
Basically, earthquake travels in the form of seismic waves. Okay, na? Like just like light rays travels in the form of electromagnetic waves. So this earthquake will also be traveling in the form of waves. Getting it?
Yes.
So that is the thing. Also, there are different types of waves of earthquake. Like there are S waves and P waves. Later on in geography, you'll be learning about that. But basically, the thing is that different things have a manner in which it travels. Like you'd have learned about longitudinal waves, transverse waves. A sound travels in the form of longitudinal waves. Hmm? Light
Yes.
travels in the form of electromagnetic waves. All those things you have learned. So this is just a name given to the waves in which earthquake is traveling. Okay, so that is what seismic waves are. Okay. Next, we are going to learn about some other causes of earthquake. Like some other cause of earthquake could be a volcanic eruption also. A volcanic eruption that can also trigger earthquake. Hmm. Or say if there's the planet Earth is hit by a meteor, that will also trigger earthquakes. Or there's some nuclear explosion. So explosions under the Earth's surface. If a nuclear explosion is done under the Earth's surface, that will also trigger earthquake. Getting it, guys? That is the thing that nuclear explosions can also trigger earthquake. As you can see this. By the way, in case of India, like in India, India has only one active volcano. Since we're talking about volcano, you guys know, like India has got only one active volcano, that is in the Andaman and Nicobar Island. It is in the Andaman and Nicobar Island by the name of Barren Island. Like there's a Barren Island. Okay, this is the Barren Island in the Arabian Sea, and this is the only place where the only active volcano of India is situated. Getting it? What I'm trying to say. So note down this name. Like this is important. Like somewhere this question can be asked. Like this is a thing of general knowledge. Barren Island. Okay. Then earthquakes could be of different types. Based on the cause, it could be of different type. Like due to some tectonic activity, when the tectonic plates will be colliding into each other, when they will collide into each other, or when they will slide past one another like this. One goes in this direction, one goes in this direction. So that is also one of the reason for earthquake. Then explosions, like we did learned about nuclear explosions, or due to collapse of buildings. Like for example, if in a given place heavy construction work is going on, and it disrupts the balance of the tectonic plates. So there also a huge piece of land mass can submerge, and that can also trigger earthquake. Getting it what I'm trying to say? Just hold on for a minute. I will call. Just 1 minute. Oh, sorry for the interruption. Yeah. So what I was saying that, like in some places, like in India, like in Uttarakhand, due to heavy construction work in Uttarakhand, what we have seen now, like in Uttarakhand, land has been collapsing. In Uttarakhand, land has been collapsing. So in some parts of Uttarakhand, land has been collapsing. Why? Because of improper construction, like tunnels, like not in tunnels, I would say, like if for example, if the buildings are constructed in such a manner where the density of the soil and density of the rocks of that area is not considered, if the soil and in the rock materials of that region is not stable. Getting it what I'm trying to say? So if heavy construction work is done, right, and if lots of heavy construction has been done on that unstable land, so over some time, what will happen? Those buildings will also collapse, and it can trigger a small earthquake. Although the magnitude will not be that much, but it can trigger earthquake. Getting the last point, what I'm trying to say here, like there's a huge piece of land mass and say that the soil and the rock here are unstable. They are unstable. So if I were to do construction over this place, and I were to do this construction for a very long period of time, for so many years, if I were to do construction on this, so since the foundation is unstable, will this building be stable on this? Will it not collapse after some time? Just tell me this thing, yes or no.
Yes, sir.
So if so many buildings collapses at one single time, so it can trigger a small level earthquake. That is what I'm saying. Okay. Also, here you one more thing I wanted to say, that earthquake is not only common to the earth, right now, like shaking of the planet, shaking of the crust not only occurs on the earth, it occurs on the moon also. So what will be it called as when it occurs in moon? It will be called as moonquakes. Getting it, guys? And these are some of the news outlets, some important news outlets. Like the first one is Melbourne meteor loud boom and earthquake felt after comet seen in the sky. Getting it now? So was the news from the date 7th August 2023. So there was a comet. Okay. So as a comet was seen in the air, in the sky. So I mean to say, like Melbourne meteor. Okay. So when there was a meteor falling towards the earth, so it produced a loud boom sound, and earthquake was also felt, right? Furthermore, you can look at this news also. Mars meteorite boom was actually planet's largest ever quake. The rumbling detected by NASA's InSight Mars rover had a magnitude of 4.7 and has now been determined to be the largest Mars quake ever. So there has been quakes on the Mars also. That will be called as Mars quake. Getting it? So this phenomena of shaking of the Earth's crust, or the basically crust, is not only limited to Earth, but it happens on other planets also. Then further look at this news. Iceland shaken by 800 earthquakes. Volcanic eruption fears rise. So in just a short span of time, there were 800 earthquakes in Iceland. Another news outlet says that it was 700 earthquakes. So somewhere around 700 or 800. Okay. Also, these news are from different dates. So yes, this is from 15 November. This is from 27 November. There might be some difference anyways. So that is the thing.